Thanks for coming on the show. Really appreciate
Thank you,
your time. So yeah, let's get into it. Like we were just talking about mental health. It's been a pretty big topic lately, especially in New Zealand, and it was pretty cool seeing the Gumboot Friday take hold in New Zealand.
Can you tell me about that?
Okay, basically, so there's this person who runs this charitable foundation, I Am Hope, and they want to raise more awareness over mental health. And one of the challenges they're doing is Gumboot Friday. And their message or underlying, what they want to achieve from that is that they want to make counseling available, free for youth. And I think KiwiBank they vowed to donate $1 per every person that posted on Facebook or put their DP as this sort of I Am Hope logo. And it's pretty cool, man. Like, I think it's so... I'm not sure. Over the years, I've seen it increase, how we talk about it. It's overly exposed. But what do you reckon is the problems now that we're not addressing properly?
Yeah.
Especially in this sort of...
Okay. Yeah. I actually think that young people have been... they've been abandoned by by government. I think they've been abandoned by adults in a lot of ways. Because
what do you say that?
Yeah, right. Because there is so much sort of people have become so caught up in their daily routines. Getting going to the work and putting the money, putting the food on the table, and working longer hours, and I think that basically that there's been more separation between families, and that families are just more and more just sort of busy. Parents are just busy sort of making the money.
Yeah.
And the kids are just busy going off to school. But that there's been more separation, and there's less time where people are spending time together. I think a lot of the technologies around like smartphones and entertainment and media, it's major. Yeah, I mean, I'm not saying that this is simple, right? I'm not saying this is simple, but I just see that there's been sort of an eroding of the ability of people to actually have really meaningful conversations with each other, and that people oftentimes are also very easily triggered.
Yeah,
I find that to be interesting. We need to talk about things. There's lots of things going on. There's lots of issues going on here.
Yeah.
But we need to have, people need to feel like they can talk about it. But I see oftentimes that people just get very offended very easily.
Well, what do you mean by you mean we're just thin-skinned, or we don't? What do you mean by we don't talk about it easily, or we get offended?
Yeah, I find that people sort of have a hard time getting personal.
Okay. So we can't communicate it well enough.
Yeah, that's what I'm finding. I'm finding like the ability to communicate emotional ideas, like I would call it emotional intelligence. You hear that term. There seems to be a reduction in the ability to sort of communicate where you're at emotionally in a situation, or that where you're at is not that important. And you're just sort of expected to, toughen up, and and just get along with, get on with it. And let's not talk about it. Let's just do. I think it's important to talk.
Yeah. Well, that's a very stoic approach to it as well. It's like, my problem, I just have to solve it. And oftentimes, I think it's real harmful to have that sort of thinking, to not, whenever I'm going through things like that, it's like whenever I do talk to someone, my mates, close mates, it just feels better. It feels like there's a lot of weight that's taken off your shoulders, and someone you got to trust that person.
That's right. That's right. And even just being able to talk about it, not necessarily that the person's going to give you a solution, right? But just that you can talk about it takes a great weight off my shoulders too.
Yeah,
I feel that way.
Yeah. What do you think about decriminalizing drugs now?
Yeah, I think that we should decriminalize marijuana, certainly.
You reckon?
I do.
That's a big topic now in New Zealand.
Yes, it is.
Very big.
Yes, it is. I think that, again, the criminalization of the act of using marijuana, which could be for many different reasons, I think really causes a lot of distrust and causes people to hide things. And I think that basically people should be allowed to make more of their own choices. Now, sometimes choices can lead to kind of bad outcomes.
Yeah.
But people should be able to make a choice so that they can learn from it. Whereas if people are told, no, you can't do that, no, you can't do that, I think that just causes people to have a sense of they like yes, yeah. to rebel. Yeah, exactly.
Well, like thinking about something like drugs that can affect your body or the way you think, your mental state.
Yeah.
To legalize that or to allow someone to recreationally take that.
Yeah.
Let's say, for example, that person does take it, goes and drives. It's a big topic.
Yes.
They go drive and they run over or crash into a car, kills a few people.
Yes.
Is that a lesson that could be avoided? Is that something that could be avoided by criminalizing it, making it more restrictive?
Well, alcohol is the obvious example here, right?
Yeah.
Alcohol is legal.
Yes.
And the majority of accidents that lead, when you compare sort of, deaths due to driving on cannabis and deaths due to driving on alcohol, alcohol is by far more because it affects the motor skills of the things you actually need when you're driving. In fact, it's interesting about cannabis because it actually acts on parts of the brain that actually cause people to oftentimes become more creative, but in this context, you become more cautious.
Right.
Now, the extreme, of course, is paranoia, and that, of course, is the negative aspect of it.
Yeah.
Okay. So that paranoia, though, but before paranoia, there's caution. So actually, cannabis seems to actually drive people to be more cautious. You don't have people getting into fights around cannabis, but you see lots of people. I grew up with lots of people using alcohol, and oftentimes the fights were around people when they would get drunk. That's when the fighting would happen. That's when the beatings would go on.
I don't ever see alcohol being illegal or even out of the market because it's such an economic driver in our economy.
Yes.
And the culture around it, the social culture.
Yes.
It's massive.
It is massive.
And, if you were to argue about drugs and the influences and the harmful influences, alcohol's big. I think there was a study done, massive study. I'm not sure if the specific study, maybe we can bring it up, but it's basically, it did about 20 factors of drugs affecting, let's say, your motor skills, your thinking ability, all this stuff. So 20 different factors. And they found that alcohol was the most harmful out of all the drugs.
Yeah.
Heroin, cocaine, meth.
Yeah.
All these stuff.
That's right.
Alcohol topped it.
Yeah, it's amazing. And that's the one that's legal, right? Yeah. So, I think there's lots of historical reasons why cannabis is currently illegal in many Western countries, but largely it was actually economic. That at the time in the United States in the 20s, there was a very highly competitive alternative to wood for the production of things like rope and paper, and that was actually cannabis, or what we call hemp. Hemp is a very viable product. Is a plant that has all of these industrial uses: rope, paper, and now, of course, all these medical applications. But at that time, the paper industry was already in place. All the industry was in place, and they basically lobbied it out and made it illegal.
For that reason?
Yes.
Right.
Yeah.
I've never heard that.
That's right. So it wasn't driven because of it was considered to be somehow harmful to the mind, or somehow it would cause you to become like socially maladjusted or something like that. No, it was actually for economic reasons. That the paper and the wood industry was already in place, but then it was being discovered actually that hemp was actually far less expensive to process and much easier to manage, and it could grow much faster, and in fact was more competitive. But because of the powers that be were already in place, that's what actually drove some of the early prohibition laws.
But at the end of the day, if someone wants to smoke weed, or they'd do it. They'd find a way.
Absolutely.
But you cannot stop.
No.
And I think now what's happening is that people are illegally doing that.
Yes.
And if they do get caught, which sometimes does happen, they do face maybe imprisonment, maybe a massive fine.
Yeah.
So you're saying that.
And I think that is
that's
detrimental to our society.
Right.
That we're locking people up for doing something that isn't actually is their choice. They were doing something probably personally, probably just within their, with themselves or with some friends or something like that. But it wasn't like causing mayhem. But yet I would just say that the repercussions do not fit the choice. Absolutely.
Does this just apply to cannabis, or what other drugs do you think should be legalized?
Yeah.
Because cannabis is just one of many.
That's right.
Major drugs.
That's right.
Yeah.
I think if we're really going to go down this path, I think we really just have to go toward legalization of many of these drugs. But what I think we have to have is just have to have real, honest discussions, and that there's the knowledge and the ideas are freely available, and the results and the data and the research is freely available, so that people can have what I would call rational discussions. Because when all this stuff when all of these other mind-altering substances are illegal, people cannot actually have a rational discussion about them because there's this fear. This is fear that if they say something about something that's illegal, that's going to somehow brand them, or that's going to somehow disable them from getting somewhere because someone's going to think that this person isn't, a law-abiding citizen. So I think that really there should be, again, people should be able to make choices.
That's very hard.
Yes, it is.
For parents that are listening, for people that, they're very, they're not open. It's hard to accept that cannabis, or let's say meth, is going to be out there for people to, consume. Yeah. But it is pretty interesting because Portugal legalized it in 2001, I think. Yeah. All drugs. And they found that a massive, significant decrease in the amount of drugs people did take.
Yes.
The negative impacts these drugs had. Yeah. The imprisonment rates. Yeah. And the overall social well-being of the state increased. Yeah. Which is,
I think,
is that an exception to the rule, or could that be the rule to a lot of countries following that?
Yeah, I think Portugal is an example of where it seems to have worked, and basically that what we're dealing with is fear.
Yeah.
Fear, and fear comes about from a lack of education or knowledge about something, a misunderstanding, or a lack of information about something. Yeah. That's where fear comes from. Something that you're not familiar with. It's natural. We're human. If we're not familiar with something, there tends to be sort of a natural, fear-like response, which is probably due to sort of survival aspects.
Yeah.
So I think that fear, unfortunately, can get in the way of trying to have what I would call rational discussions about, decriminalization and legalization.
Right.
Yeah.
Yeah, it's very interesting. I think we will. They're going to legalize it. My bets are in the next 5 to 10 years, it's going to be legal.
That is mine too.
It's, by putting these barriers, you're going to force people to take other synthetic drugs that are even harmful.
Yeah.
You don't know where it's coming from, all this stuff.
Yeah.
But now if it's legalized and there's actual real processes that, ensure they're safe.
Yes.
I think this could be beneficial in the long run.
Yeah, we can treat this stuff as health issues, health topics, not as criminal topics.
Huh. Yeah. Interesting. But yeah, that was a good segue. But okay, so tell us your background. Tell us. That was pretty cool. That was really fun.
Well, my background actually, I was raised on what you would call today a hippie commune. Yes. Yeah. So So basically, my parents were like the hippies from the 1960s.
Right.
In the United States, they were the ones that were protesting the Vietnam War. They were the ones who were basically coming from very well-educated families, in some cases wealthy families, and just decided, you know what, we don't want to toe the conventional line. We don't want to live in this conventional society. We see that basically the United States has become the armory of democracy. We are basically we are the largest weapons dealer in the world, and we are bringing democracy places, but really in the end what we're doing is we're oftentimes installing our own people that are open to doing business with us. This is in particular Central America and South America, and the results have been absolutely devastating. We've set up all kinds of crazy right-wing governments in Central America and South America, which have been so detrimental to the populations of these countries. So my parents were picking up on that. They were realizing that, yeah, this great American dream is actually due to the results of some pretty terrible treatment of other countries that are not nearly as well developed, not as wealthy, don't have as much a sort of a developed government and infrastructures, and that we basically we've grown up thinking that, growing up with all these benefits, but we're starting to see where these benefits are coming. They're coming off the backs of other countries and people and cultures that are getting destroyed as a result of the way of life in the United States. So I think there was sort of an awakening going on.
Okay.
My parents were awakening to that.
This was
Anyway.
in the 1980s, 70s?
So this would have been in the 60s.
60s, okay.
Yeah, this was in the
Yeah.
60s. So I was born in 1970
Right.
and in California. And then my folks basically ended up in northern New Mexico. And I grew up on a commune. It was called the Magic Tortoise. And that was the name of the commune. And there was others. There was
Magic
the Magic Tortoise. There was another one that was also happening simultaneously. It was called New Buffalo. And then before that one, it was called Reality Construction.
Yeah.
And this is where my parents were
Right.
associating with. And then there came this one guy, and he said, "Hey, I'm going to buy this land in this beautiful rural area, and I would like to attract like-minded people, and we're going to live a self-sufficient life. We're going to, build together. We're going to grow our food together."
Yeah.
And that's where I grew up.
Right.
Now, all of these people that my parents, though, they all came from educated families, like from back east, particularly. When I say back east, like the East Coast, some of these schools that you're interested in going to.
Was
father
it in the Rajneeshi commune?
No, the Rajneeshi commune was in Oregon. But that came much later.
Much later.
Yeah, I would say that was in the 80s.
Right.
Have you seen that documentary?
I have.
That's an amazing
really
documentary.
Interesting.
Yeah.
Very interesting.
So no, the commune that I grew up on did not have a spiritual guru or a spiritual requirement of a belief.
Yeah.
It was more about let's learn from the Native Americans, the Pueblo Indians, and the way that they interact with the land, and the way that they are not concerned about ownership of private property, but about living and working on the land communally.
Yeah.
And so that's
it's a very social, connected community.
Absolutely.
Right.
Yeah. So that was kind of the atmosphere that I grew up in.
Yeah.
So it was very free. It was very free thinking, and I think I benefited from it greatly. I mean, look, I've ended up here, becoming a lecturer at a traditional university. Yeah. So although I came from this highly alternative background, I think it's enabled me to sort of plug into more traditional or more conventional mainstream stuff too. But I don't necessarily, I'm not, I can be in both.
Right.
I feel like I can. I think that the benefits of free thinking has enabled me to thrive in say, the place where I am now, which is AUT, the Auckland University of Technology, which is a fairly traditional university in its approach to teaching.
Yeah. So what was your PhD about? What did you study?
Yeah. So my PhD is basically physics, but it's applied to the interstellar medium, so the space between the stars. We looked at an area that goes by different names. One is called Rydberg physics, named after this Swedish guy Rydberg, who was the first to begin to kind of understand some of the ways in which electrons, the way in which atoms emitted and absorbed light. Right. He began to come up with a numerical model for that. But anyway, the area that I really worked in was what I would call giant cosmic atoms. So we were investigating the nature of atoms in the cosmos. So we understand at this point conventionally that atoms make up everything that we are familiar with, right? This microphone, this table, we describe the matter from an atomistic point of view. And we've come to understand a lot about atoms on the atomic scale. by studying, at particle accelerators, and we've come to understand their behaviors. But their behaviors are always within a certain framework of conditions, like what's the pressure, what's the temperature, what's the density of the matter.
Yeah.
And, we're familiar with the conditions here on Earth that you've grown up with, everyone else has grown up with. Those conditions are the conditions that atoms have been studied deeply.
Mm-hmm.
The question is, what happens if you start to go to you start to investigate the nature of the building blocks of nature, atoms, under totally different conditions, like outer space, which is what we call a vacuum, which is basically the lack of stuff. So typically, you might have, like the air between us, right, has, billions of atoms.
Okay.
The amount of atoms in 1 cubic centimeter of this table is 10 to the 24 atoms, right? But when you go, so extremely high, right?
Yeah.
Now, between you and I, it's what we call a gas. So of course, there's going to be far, far fewer atoms, but it's still, trillions of atoms.
You can't even think about it.
Yeah, right. So it's hard for us to really imagine this stuff. But when you start to go into outer space, you get to situations where the amount of atoms per cubic centimeter is 1 atom per cubic centimeter.
Fuck.
Yeah. So that's truly a vacuum.
Yeah.
We can't even create those types of conditions in the best vacuums on the planet. So if you go to like a particle accelerator, like at CERN, for example, you might get down to maybe you get to a certain vacuum level, but now if you go into outer space, it's 1,000,000 times less stuff per cubic centimeter than what you could get in the best vacuums. And again, a vacuum is the lack of stuff, the removal of stuff. But the best vacuums here, compared to the vacuums in outer space, is like there's a difference of 1,000,000. So you'll have 1,000,000 more particles, per cubic centimeter than you would in outer space.
Yeah.
So now the question is, so now you've got conditions that are so wildly different than anything we could create here on Earth.
Yeah.
What is the behavior of atoms under those conditions? So this is science, right? Science wants to investigate new phenomena, wants to investigate the behavior of atoms, in this case, under totally different conditions. So that's basically what my PhD work was investigating the nature of atoms in the space between the stars.
Right.
Or cosmic atoms.
So, how long did this take to understand it?
Yeah. So in my case, it took 10 years.
10 years. This one PhD study.
One PhD study. Yeah.
So, how did you first read about all the things that was studied, and then you applied that question and try to find it?
Yeah. Basically, the first couple of years was just spent learning about all of the research on this topic, and then after that, we began to engineer certain astronomical observations that we were going to make using enormous radio telescopes to begin to answer the question about the behavior of these atoms. Now, the real reason why we got into this was because there was a paper published in 2000 by a Canadian group who basically said, we've looked at the behavior of the spectral lines. So spectral lines is the emission of light from atoms. Yeah. And it turns out that in the cosmos, because there is so much space between the atoms, it turns out that the electrons can exist in very high principal quantum number states. And what that means is fairly far away from the atom compared to what we would be able to observe here on Earth. So here on Earth, the electrons never really get that far from the atom. Yeah. But in the cosmos, because there's so few things, the electrons can still get fairly far from the nucleus of the atom, but still be associated with it. And when it starts to get very far away, and you look at the transitions of these electrons when they're far away, it turns out that the light that's emitted in those transitions are not at visible light, or optical, what we can see with our eye, but are at radio wavelengths. That which you pick up with a radio telescope. The same types of wavelengths that you use when you tune in your radio to listen to your favorite radio station. It turns out that electron transitions occurring very far from the atom emit light at radio frequencies.
Right.
Yeah. So that's sort of the background a bit. So there was this Canadian group, and they published some measurements that they had made about the behavior of this light as it was being emitted or being absorbed. And what they published was a behavior that was entirely not predicted by quantum mechanics, our most fundamental theories of the behavior of atoms.
Yeah.
Okay. So up until this time, quantum mechanics was predicting very well the expected behavior of electrons making transitions at very high principal quantum numbers. This guy published some results that showed that the behavior of these spectral lines were diverging entirely from what was predicted, extremely different from what was predicted.
Yeah.
And that's where my supervisor, Sergei Gulayev, was very interested, because his area was these cosmic atoms, or what are known as radio recombination lines, because they're spectral lines, but they're at radio frequencies. That's where we get radio recombination lines. So he was an expert in radio recombination lines, which were first observed in the 60s, and then many observations and detections had gone on, and pretty much were the behavior of the atoms and the light that was being emitted at radio frequencies was all fairly consistent with what atomic physics was predicting. And then in 2000 comes along this guy, and he presents some results that says, oh, what I'm observing here is completely different than what's been predicted. So that's what attracted me and my supervisor to the topic. To make a long story short, well, I know I've rambled on, but
No, that's really interesting.
bring it to some closure,
Yeah.
it turned out that it wasn't Mother Nature doing something that was unexpected. It turned out that the person was using a novel data processing technique that introduced artifacts into their results that they then predicted to be coming from Mother Nature.
Well, I'll repeat it again.
Okay.
Okay. Yeah.
So, in astronomy, when you collect data, you oftentimes have to process the data. And in the act of processing the data, this person used a novel technique in processing the data.
So not the common technique most people use.
Correct.
Okay.
Not the conventional technique at the time, but a novel technique, which actually had good benefits. It was enabling them to avoid certain problems that the equipment was introducing into the data that was causing the very weak signals to be lost. So he came up with a technique that would enable them to detect more sensitively, weaker and weaker signals, because it turns out that all the signals that we're dealing with are extremely weak, and that the equipment, the electronic equipment that's receiving the signals from the cosmos is introducing lots of artifacts. So a lot of that was known, but then this guy went on to introduce a new technique, but it turned out that that in itself had some new artifacts that the person was not aware of. And it turned out that we came to understand that in fact it was artifacts that he was interpreting to be something that he thought was coming from the cosmos, but in fact it was coming from the technique that was being used to process the data.
Right.
And papers were published based on these results, saying, I have come up with evidence for a new behavior of nature. But it turned out actually it was a behavior of his. So was
your PhD trying to replicate that to get the same result?
My PhD in the end turned out to be correcting someone's mistake.
Right.
Yeah. But the first part of it had to do with trying to understand their technique, to reverse engineer, to replicate. Indeed, we did. Yeah. We replicated it so well that we could show that the technique was in fact producing the very signal that he was claiming was coming from the cosmos.
So what happened with his paper? Was it just amended that he used?
No. Science is made up of human beings, and human beings are full of successes and failures and egos and arrogances. Right. And the paper's published. It was in 2000. By the time I was looking at this stuff, it was sort of 2010 and things like that. So basically, we just began to publish our results, basically bringing into question. That's normal. In science, people publish a result, and if it turns out that that person was on the right track, then someone else will come along and also be able to replicate it and say, yep, we find a similar result, and whatnot.
Well, that's how you find truth.
That's right, exactly.
You have to replicate it.
That's right.
If it can be replicated, then therefore it's objectionably
exactly.
True.
So in this case, we began to attempt to replicate, and we were finding different results.
Right.
Not the results that he found. In fact, the results that we were finding were actually more consistent with what had been already known from before.
How important is that in the scientific community? Like, how many times do you guys see papers that are published where it's like, shit, is this really true?
Yeah, it happens a lot.
And then how long does it take for them to either be proven or disproven? Because it's such a long time. These are years, you know. These people dedicate their lives to this.
Yes.
And, you know, maybe someone might, you know, say something that's not true, and it takes another person 10 years to find out, well, this guy was actually wrong. So does this happen more often than we think? It
does. It actually happens a lot.
Right.
And that is normal.
Right.
That's science. You know, you try and you know, scientists, of course, are trying to make sure that their results are, you know, reproducible. And
is that why they have methods?
Yes.
So if someone were to replicate it.
Absolutely, and that's the whole idea. In fact, that was one of the problems in the Canadians' paper, was that they did not describe or explain very clearly their method. And in fact, we had to really go back and try to understand. And the method was published over too many papers and would give a little information here and a little information there, but it was never that well explained. Furthermore, the authors did not share the raw data. All they shared was the processed results. And so the processed results showed this you know, significant departure from what was expected, but they didn't share the raw data. And that was another problem. So we really had to go back and actually remake the measurements using conventional approaches to show, and we found, I should say, that we don't see this behavior. But we actually reverse engineered the technique they used, and we showed that technique introduced that behavior.
Right.
This stuff happens a lot.
And this took 10 years.
It took 10 years.
Wow.
Yeah.
A long time.
A long time. Yeah.
So
and to this day, the author of the original paper does not believe my results.
Right.
Yeah. And that's normal.
So there has to be a third person.
Yeah.
To
yeah. But to his credit, you know, there needs to be some more measurements made that we pretty much showed that no, we're not seeing anything like what you were saying, and we've been able to reproduce a model that actually shows the technique that you used actually makes that result that you're claiming is coming from the cosmos.
What happens if, you know, let's say a scientist publishes a paper, and that paper is so phenomenal, so, you know, everyone's like, wow, and then they win an award, but then let's say 10 years, 20 years later, a guy does the same, you know, replicates it, and it can't be replicated.
Yeah.
Or it's not true.
Yeah.
Has that happened?
Yes, it has.
Do they get, does their award get taken off them, or?
In some cases.
Right.
In some cases it happens. Yeah. This seems to be really happening a lot in medical fields, where there's so much pressure to make money off of findings.
Is it pharmaceutical?
Yeah. This is a problem. You know, this is where money starts to really mess things up.
How much? Yeah. How is it in researching? Does money play a role into it?
Yeah. Well, it's.
Where do they get their money from?
Right.
How does the funding and stuff work?
That's right. You know, different fields have different sources of funding, of course. But if the funding is tied to, there has to be a engineering or an economic spin-off, then that starts to put the researchers in a bind, because, you know, they are being given money with the expectation that there's going to be like a practical, you know, economic benefit. That's not science. Science is curiosity driven. But how could it be that way? Yeah. How could it possibly be that way?
Yeah.
Now, there have been many, many spin-offs from curiosity driven science.
Yeah.
We can talk about all the electronics that we're using for this interview today.
Yeah.
All that stuff has come about by people exploring electricity and magnetism,
Yeah.
and exploring the nature of atoms and molecules and the behavior of electric fields and whatnot. But all that stuff was being driven by curiosity, largely. Yeah. So when you start to get a lot of like
Venture capital money.
yes, venture capital money, that's where things can become kind of tricky with this kind of pure curiosity-driven research.
But sometimes that gives some people some negative motives to fake the data.
That's
or
right.
Fake the information.
That's right. And we're
and
seeing
that could cause a lot of consequences
Yeah.
for people, especially in the pharmaceutical industry.
yeah.
You know, if something wasn't it what was it? Broccoli or something had more, was it orange, had a certain more vitamins than it actually did, and everyone thought it was like, this is so good for you, and then they found out that actually the scientists actually put one or more zeros than it really was, and everyone thought, wow, you know, this they thought this was so amazing. Now the scientists, you know, came out and said, no, sorry, like, I made a mistake. And then that could, because it had a massive economic cost because more people were demanding this sort of fruit rather than this one.
Yeah.
It just shows that, you know, humans are
humans.
humans, yeah, they make a lot of errors.
Yes, we
But
do.
what fascinated,
And that's what science
Yeah.
is. I mean, if you are truly practicing science, that they tend to correct those errors over time. Because
okay.
someone comes along and does another measurement and says, yeah, well, I'm not finding that result. So that is one of the characteristics of if you're doing good science, is that self-corrective is built in. But now things are becoming much more challenging.
Yeah.
Because there's so much sort of incentive for profit
Huh.
driving this stuff.
Yeah.
At the same time, it's interesting because you can look at where the greatest innovations are happening in space technologies now. They are actually happening in small company or private companies.
You mean like
Take
SpaceX?
SpaceX, take Rocket Lab,
And
you know,
which one is
Virgin Galactic.
Galactic,
I
yeah.
think, yep,
Yeah.
yeah. So actually, those are cases where
But they're
more
mission-driven.
risks are being, yes, it's
But they're
mission driven.
mission-driven.
Yeah, they are mission
You know,
driven.
like SpaceX,
Yeah.
Elon Musk wants to go to Mars.
Yeah,
Or Virgin Galactic, they want to make space travel more affordable
yes,
for people.
yeah,
And what's the Jeff Bezos' one?
uh-huh.
He wants
Oh, yes.
to mine asteroids.
Yeah.
So these guys have, you know, they have goals. They ultimately want to advance us, and people are attracted to that.
Yes.
And people are willing to dedicate their lives for
Yeah.
that mission,
Yeah,
which is really fascinating as well.
absolutely. And I think I think people can latch onto those ideas easily without being specialists. Like, oh, wow, we're actually going to go to another planet.
Yeah.
Yeah, people can understand that. It doesn't require a PhD to understand
Yeah.
that stuff. So that kind of stuff, the idea of being able to travel to a new place. You know,
Yeah.
humans have been spreading out ever since humans have been writing about themselves. Right? The history of the expansion of, of humans and like, for example, the discovery of the New World, right, by Christopher Columbus.
Mm.
Yeah, well, the guy thought he was finding a way to India, and he thought he found India. Well, it wasn't India. It was
Yeah.
what we've now come to be called North America.
Yeah.
Actually, it was more like Central America where he landed. But it was being, he was being financed by, I think, the king and queen of Spain at the time.
Yeah,
To try to find,
heavily.
and it
Yeah.
was economically driven.
Yeah.
So expansion is economically driven, and so that's why I think.
That's incentivized. Like,
Yes.
we are incentivized
Yes.
to, aspire to things that give us rewards.
Yeah. Yeah.
But how realistic is Elon Musk's goal? Going to Mars.
Oh, I
Is it
think,
realistic?
Yes, I do.
Right.
I think it's realistic. I do.
What's the time frame you reckon?
I think.
Based on the technology we have right now.
Yeah, I think within the next 10 years.
Reckon.
Yeah.
And will they be able to come back?
Good question.
Huh.
I mean, look at the revolution that's happening now in 3D printing.
Yes.
Right?
Yes,
You are now 3D printing more and more things.
yeah.
And
Even organs.
That's right.
You know,
Organs,
everything.
houses, more and more things are
Yeah.
being 3D printed. I think that this technology is truly going to revolutionize things where basically you can start to get basically 3D printers on Mars. These large-scale 3D printers are going to start to, and they can possibly go ahead before humans are largely there and start to 3D print structures.
Right.
Yeah.
What about the atmospheric conditions,
Yeah.
the environmental conditions?
Yeah, it's a good question. So Mars, as far as we can tell from all the planets, it's the closest to Earth. But still, the average temperature of Mars is, I think, like negative. The average temperature is like negative 50 degrees Celsius. Yeah,
It's
right.
cold as.
So it's cold as,
Yeah.
right? But if you were to compare, say, the average temperature to our other near neighbor, Venus, which is right one planet toward the sun, the temperature conditions there are extremely much higher.
Right.
Yeah. So the conditions there are even far, far farther from our conditions here on Earth. So Mars actually represents the closest to the conditions that we have here. It's still, from a biological point of view, as we are today, if suddenly we were all just magically transported there, we would all, perish, as far as we can tell.
So hot.
No, it's because it's so cold.
So cold.
On
Away
Mars.
or-
On Mars.
On Mars.
Sorry.
okay.
Yeah. Venus.
Yeah,
You're
yeah.
absolutely right. Yeah.
Yeah,
Venus is the other extreme. That's the example of what we call a greenhouse effect gone extreme. And this is what scientists are very concerned about today. That we could drive our atmosphere toward a Venus atmosphere.
Why is it like that? Why is Venus?
That's a good question. I don't know that much about
Yeah.
Venus, but I can tell you that the temperatures are extremely high.
Okay.
So, for example, when the former Soviet Union were first starting to reach Venus
Okay.
by sending probes, and they didn't get there the first time they tried. I think the first time, it exploded, like in the launch phase. The second time, it completely missed Venus, and the third time, they got it going into the atmosphere, and then it disintegrated before it ever got to the surface. And I think possibly the fourth time, but we'll have to look at it precisely. They finally got to the surface, but the thing only lasted for about an hour, because the pressures were so high and the temperatures were so great that basically iron just melts. It's so extreme. And and the atmosphere there rains acid, the kinds of things that are pretty nasty for us.
Yeah.
So that's an extreme example of what we call a runaway greenhouse effect, where the atmosphere basically allows energy from the sun to come in, but then when it re-radiates off the surface at a longer wavelength, it gets trapped by the atmosphere and then just begins to heat up and heat up and heat up. And of course it reaches some equilibrium temperature, and that equilibrium temperature though is way outside of our
So that's closer, and then Mars. So we're in the middle.
Yeah, right. So
okay.
right. So there's sort of going toward the sun is Venus, and then going from Venus away from the sun is Earth, and then going Earth away from the sun is now Mars.
Okay.
Yeah.
And you're saying that Mars could be habitable, but would need special. How could, if Mars is that cold, how can it be habitable?
We would have to build living spaces, living structures. Yeah.
So we couldn't possibly create sort of
biospheres.
Yeah, biospheres.
Yeah.
Could we possibly do that?
Yeah, I think that we can. I mean, I think that.
Would it be in our lifetime? That's the question.
Oh, yes, certainly.
In our lifetime?
Yes, certainly.
Okay.
Yeah, I'm fairly confident.
Really?
Yeah, I'm fairly confident about that. Yeah.
In our lifetime, we'll get to see someone there building a habitat.
Yes. Yeah.
For human beings.
Yeah.
Fuck. Yeah.
Yeah. No, I do.
But what other?
I mean, look, with Mars, we've sent so many probes to Mars, both orbiting and crawling across, and so we've successfully landed many probes on Mars.
How long does it take, actually?
It takes months to reach
long.
it. No, it's not that long. Think of voyages from the old world, like Europe, to the new world.
Okay,
It was also taking months.
Yeah.
And think of all the loss of life that would happen, and ships just sinking and all that kind of stuff.
Yeah.
Just you wait. That's going to happen too with our next space age.
Yeah.
There will be major catastrophes.
Yeah.
But that's the human story.
That's how we advance.
That's how we advance. Yeah. Yeah.
Which is it's pretty incredible, how we have these what seems so audacious dreams that are becoming real in a way.
Yeah. Yeah, like science fiction becoming
10 years ago,
non-fiction.
If you say that, everyone's like, you're fucking crazy.
Yeah.
Like, what are you talking about?
Yeah.
But now it's actually a reality that we could possibly see one day.
Correct. And that's largely being driven by technology.
Yeah.
You know, the ideas are so far ahead of a technology. The ideas that we have as human beings now, particularly scientific and technical, are so far ahead of you know, our technological level right now. But when you read science fiction, that's basically people predicting the future. And if you read older science fiction, you see that many of those predictions are coming to pass now. We're living in them.
Right.
Yeah, so science fiction to me is nothing more than a predictor of the future.
Yeah, but don't you think these scientific predictions, these advancements, are sometimes driven by entrepreneurs that have these audacious goals?
Absolutely.
Yeah.
Yeah, and I think that people like Elon Musk, I think, you know, he is an example of that.
Yeah.
You know, he also happens to have a lot of access to resources, capital.
Yeah.
But you know, to me, he's this fascinating sort of balance of, you know, a person who, you know, thinks very practically, but also thinks audaciously and wants to invest, you know, his ability to generate large sums of capital into these next major steps into becoming multiplanetary.
And how important is that level of thinking? That should most of us aspire to think practically yet also audaciously about these ideas?
Yeah, I really
and
strongly support that.
And how is university fostering that? Is it fostering that?
Yeah, that's a good question.
Yeah.
I think in many ways I find that traditional universities are not doing a very good job of that. I think that there is there seems to be this emphasis on just trying to get a job out of the university. Like, I'm going to university because I need a job. Universities that's not how universities started. That's not how universities were for the most of the time that universities have been, you know, part of our civilization. They were the places where the misfits went. They were the places where the total geniuses went.
Yeah.
They were the places the people who didn't fit into the mainstream who went.
Yeah.
And explored ideas. And many of those ideas are now what we live today, you know, and enjoy from the spin-offs of that stuff.
Because they were passionate about learning.
They were. That's right.
Yeah.
And so those were the kinds of people that ended up at university.
Why did we change? I'm not saying for the negative, but obviously it's such a positive aspect that everyone has the opportunity to come to university. But why has it changed to? Why isn't it that people are engaged more? That they want to really learn it rather than just, you know, getting their GPA or their you know, A or.
One word.
What?
Profit. When profit gets into education, it messes things up. I honestly think that education is an exploration. It's messy. It's not engineering. It's not efficient. Education is about exploring things, making mistakes, struggling, going from one thing, trying something for a while, trying something else. That is what education is. It's not something that can be streamlined. Education is tricky. Education is crooked. Education is costly. But the spin-offs to me are so much greater. But there's this effort to try and commodify, try to over-engineer learning. And learning is a very personal process. People learn in very different ways. And therefore, I'm very concerned that the profit motive in education is...
You mean university tuition and all that stuff?
Yeah.
Yeah. So do you think that plays the biggest role in whether or not, or why it's structured the way it is, why we're motivated as students? First and foremost, we're motivated to get the top grades, and the admissions, they want to get as many people in as possible, so they can get the tuition. So you're saying that there is strong enough motive that it skews the system in a more negative direction?
Yeah, I do. I think that the entry requirements at universities have been dropped, and so that everyone can go to university. Now, I am all for free education. I am all for free university tuition. But I think that we should have higher standards, that universities are not for everyone.
Right.
Not for everyone in the sense of the way that they used to be.
Okay.
They used to be the places where really those who were very intellectually driven were not just interested in some economic benefit, but were interested in something because of curiosity, because of how could it possibly be that way, and asking questions which were really driven by curiosity. And I think now a lot of that has been removed. Basically philosophy has been systematically removed out of education because you can't engineer philosophy. You can't engineer creativity. Those are things which are, again, they're messy, and that's okay, and that should be allowed for.
But the interesting thing about that is that, although we can't put a number on how valuable philosophy or creativity are, these are the thinking processes that have led us to live the lives we have. Because people were creative to ask these questions.
Correct.
Could we live in this way? And then they worked and then found that solution. But now to de-emphasize these, where on a micro level we might be moving, but on a macro level we might be not advancing to the rate at which we could be.
It's interesting. I call it, I think of it as, or the term that I've heard, cultural lag. So what you have is you have a new technology that comes around, but the culture is not that set up to take advantage of it, and it takes time to sort of catch up to some of these new ideas, say. So there's always this lag between the institutions that are in place and the way that they operate, and then there is a new technology that comes and just completely redefines the landscape. That's what's so amazing about invention, is that it completely redefines the very way in which we do things. But yet you've got these huge institutions all set up around a certain way. And then something completely new comes along, but they're not set up to and so that's what I like about technology, is that it's continually, it just redefines the rules.
Constantly.
Constantly.
Now AI is gonna, revolutionize the way we think about systems or how the world works in a way. And it's fascinating.
It is.
So fascinating how we've come to a point that these are possible. And it makes you think about what else is possible out there. But what made you, so you're a free spirit, and what made you sort of come into science, or what made you more so come into astronomy and physics and mathematics? These are so, I'd say, rigid and truth and fixed.
I don't think so. I'm glad that you kind of put it out that way. If you take a conventional view of science, you get that view from textbooks.
That's
okay, right? Right? And there you go, and you're looking at this textbook, and it looks so logical and so final. But for every logical statement that's made in a textbook, there was 1,000 illogical statements that were made to reach that point. But all you get in the textbook are the results that have stood up to the tests of experiments and rational testing and rational thinking. But there was lots and lots of other things that came before that. But none of that stuff ever gets put into the textbooks. That's where you get into the history of the topic, or like the history and the philosophy of science, for example. But all that stuff has been systematically removed out of the curriculum. So all you get are strictly the facts, the things that have stood the tests of time. And so that's where I think the idea that, it's so rigid and it's so concise and it's so logical. But in fact, those are just the things that have stood stood up the tests. But the textbooks don't show you the other side, the human side, all the failures. There is way, way more failures that have gone on to reach that point than just that one correct point. There's all these mistakes that were made. But that's what science is about. It's okay to be mistaken. And so oftentimes scientists who are at the cutting edge, we are constantly in a state of sort of uncertainty. But yet science is oftentimes presented as certainty. It's not. Certainty is when you've taken an idea, tested it out, and you've found that your model predicts something that Mother Nature is actually, like you go and my model predicts this, and then you go and look and say, oh yes, Mother Nature is in fact indeed that what this model predicts is what I observe in nature. Oftentimes models are developed to try to quantify some model that is predicting what's being observed. Yeah? And so the model is oftentimes an attempt to reflect some natural phenomena. Okay.
Yeah.
Now the model gets developed along those lines, right? And the natural phenomena in science is attempting to adapt the model to natural phenomena through the so-called scientific method, which is really about testing it to see, does it actually continue to predict what is happening in nature, the natural phenomena. But then some new technology comes along that allows you to measure something that is 10 times weaker than what that technology was able to do before.
Mm-hmm.
So now you're able to measure something new. And now the question is, does that model that has predicted, that is correctly predicting everything we know up to that point, does it also predict this new phenomena that we can now measure? Well, it's not new. Mother Nature is Mother Nature. They don't care whether we're there or not, but what we're starting to do is become sensitive to some new dynamics. That's where the new technology comes in. And now the new technology allows to make a new measurement. And now you go back to your model and say, yes, our model, which has predicted everything so far, does it also predict these new dynamics? When we put these new parameters into our model, does it predict this new measurements? And if it does, then you say, oh, well, this model is really doing well.
Yeah.
But if the model cannot predict these new dynamics, then you've got to go and ask, what's wrong with the model? That's science. This kind of checking and going into some new parameter space and asking, okay, does this model now continue to predict these new measurements? If it does, then you can say, wow, that model is really something. Einstein is a classic example of that. The guy made many predictions. The most famous one is general relativity.
Yeah. Well, explain to people that don't know what.
Yeah. So basically, what he did was that he connected space and time in a highly mathematical way.
Okay.
That had never been done before.
Right.
And it predicted many bizarre effects, but were totally untestable at the time because the technology didn't allow for it.
Right.
But as technology developed, these effects that his model was predicting were starting to be found. And in fact, every prediction of Einstein's general theory of relativity have been found to be correct when we go to test them using new technology. So that's what's made his theory so successful.
Yeah.
We are now in the situation where in astronomy or cosmology, there's this new phenomenon, dark energy, dark matter.
What are they? Like,
these are things that don't
know?
Exactly. These are phenomena that new technology is detecting that simply are not predicted by our most sacred, most successful. Exactly. And you see, laws in physics are that which could be otherwise. They're not laws in the sense of something absolute. They're mathematical ideas that predict something that you're observing. But as soon as that law no longer is predicting what you're observing, you've got to go back and modify that law. So science is about breaking laws. So you see how science is presented in traditional education or in textbooks as somehow, everything was just so clear and so obvious.
Yeah.
And now you're expected to learn 3,000 years of suffering and struggle to understand all this stuff in like 2 or 3 years in your courses.
Yeah.
It's nonsense. But yet that's this way in which we oftentimes see people attempting to teach science.
Right.
And I think it gives a very skewed and a totally, I think, a misinformed picture about science. Science is about the unknown. Science is about dealing in confusion. Once something is known, it becomes engineering. Now, I'm not saying engineering is somehow bad or negative or less.
Yeah.
Engineering is important. They've engineered all this gear.
100%.
They've engineered the roads. We're engineering the airplanes, the new spacecraft. All that stuff is using the hard-won knowledge or understanding through asking questions about, but how could it be that way? And all those spin-offs come from that. All the engineering comes from all that stuff. But science is about the stuff that doesn't make sense.
Yeah.
The stuff that is uncertain.
Mm.
So I hope that can.
I see. Yeah. So following that, how much of the scientific sci-fi movies are accurate? Let's take Interstellar for example.
Yeah.
How when they entered their black hole, how is it transferring them to another galaxy, or how is it doing that? What's the science behind that?
Yeah.
Or is there actually science proof behind that?
Yeah, I think there is going to be a lot of surprises there. Yeah. Black holes are a prediction of Einstein's theory of general relativity. It represents an actual breakdown in the mathematical model.
Okay.
So it predicts certain things, but it's really just basically the point where the mathematics of the model fail. So what is going on inside a black hole and whether it's going to take you somewhere else, that is at this point a totally open question, as far as I know. Now, I'm not an expert in black holes, but as far as I can tell, there's going to be plenty of surprises.
Yeah. What are wormholes in?
So wormhole, I'm glad you asked that, because that is also a prediction of Einstein's theory.
Right.
Now, the guy's
theories, was genius then.
Yes, and he's predicted all these things which have turned out to be, that's right, 1915 I think is when, or 1914.
That's 100 years
ago. Yeah.
With none of these technologies we have, and he was able to think.
Yes, that's what was his genius, was that he was able, through the use of his creativity, his imagination, and also his understanding of physics and mathematics at that time, was able to go further than anyone had before. Which is sort of, for me, that's the hopeful aspect of humans, that we can do those types of just amazing feats, amazing feats.
And apparently, like, when he came up with the theory of general relativity, the idea of it was actually in a dream of seeing what the elevator or him. Can you explain that if you know the story?
Yeah, I tend to sort of be a bit dubious about these things.
Is it true, or is it just some people just say that?
I don't know. I mean, honestly, I'm not sure. I'm not sure. I think he asked certain questions, like he asked the question, like, what would it be like if I was traveling at the speed of light? What would I experience? How would I perceive reality? I think those were one of the questions that I understand he did ask and that was one of the thought experiments that he was using to begin to develop his theories.
Yeah.
Like
how does space and time work? Because I watched Interstellar recently, and they went on this on that planet, and they said 1 hour was equivalent to 10 years.
Right.
Being on that planet.
Right.
How does that work? Because my idea of time is continuous.
Yeah.
And how does time go faster for someone else and slower for others? Like, it doesn't make sense.
It actually comes out of the mathematics of the theory itself. You actually start to have this effect of what's called time dilation, where it is the way that we tell time is that we are seeing something go click, click, click.
Yeah.
But when you have objects who are starting to move relative to one another at significant velocities, the rate of those clickings begin to change. And so your very clock rates begin to change. And that's why we get these with these predicted results, that actually time moves slower when you're moving faster. Because if you can imagine, let's say that you and I are here, and there is 2 clocks.
Okay.
And they're synchronized. Click, click, click. And now, and it's a digital clock. And now I leave and start to move very, very fast in some direction. And I have my clock in my whatever spaceship, and it's going click, click, click. But when I begin to look at your clock, because I'm moving at some significant fraction of the speed of light, it's taking, and light travels at a fixed rate, at a finite rate, that's our understanding.
Yeah.
I'm going to see those clicks arriving later and later as I move faster and faster.
Huh.
That's where these differences in clocks arise from. The fact that light does not travel instantaneously, and that the clicks are you hearing it or you seeing it. And now, but what is seeing? Seeing is electromagnetic waves. Electromagnetic waves, that's light. I'm seeing your clock, but your clock is now taking it longer as I'm increasing my velocity, it's taking longer for the photons to catch up.
Yeah.
And of course, eventually, if I am moving at the speed of light, then the last thing I see on your clock becomes frozen, because no new light ever reaches me, because I am moving at the same speed that the new light never reaches me, to update the clicks on the clock that I'm seeing with my light, with my eye. So our concepts of space and time are due to our very limited way in which we experience reality. We experience it through this eyes, we experience it through our ears, through the touch on our skin, through the sound that we're hearing. But if you start to think about it, actually, we construct reality out of some pretty limited information.
Yeah.
And yet,
so is this constructed, this time, essence of time? So it's basically constructed. Like our reality of time is not applicable to other planets or other. Like the way we experience time is different to the way other people experience time.
I think that time is one of these least understood ideas in physics. Yeah. Yet we talk about time all the time. And we set things to, we're worried about time. Time's become currency, right? It's become so, like our time is so precious. I have so little time, or, we need to meet at this time. But in fact, time, from a physics point of view, is a complete mystery.
Right.
Yeah, we really don't understand time, I would say.
Yeah.
And is time, as we understand time, it's the way in which we reconstruct it with our sensors, our biology, with our brain, and the way we process data. But one of the things is that time, we perceive time because of how we are moving relative to one another. So we don't move too fast relative to one another. Like now we're both sitting here, right? So we're sort of like stationary.
Yeah.
Oh, but you could be sitting here and I could be driving on the motorway going 100 kilometers per hour, say. That's typically, maybe a couple hundred but now if you're in an airplane, a little bit faster. But it's because we perceive space and time because of the relative velocities between us. But as the relative velocities between objects start to grow larger and larger, you start to get some of these relativistic effects that we are just simply not aware of in our usual day-to-day. But as you begin to move at fractions, even like 10% the speed of light, we begin to detect these effects that are predicted by Einstein's theory of general relativity, which tied space and time together in a way which had never been tied together. And then it started to predict all these, what we would call bizarre, but they're only bizarre because of our relative motion to one another and to our experiences on this planet. But as objects begin to move at significant fraction speed of light, you start to see new effects. And those new effects are built into the theory of general relativity. So our experience of space and time is because of how we interact with space and time. If we begin to develop technologies, propulsion systems that allow us to start moving at much faster speeds than what we currently are able to move at, then we are going to start to see new effects. But we make up the world as we know it. The reality is based on the way we interact with it. Technology is allowing us to interact with our surroundings in ways in which which our ancestors weren't able to. And then there will be the next generations and their technologies, and they will be interacting with space and time in a new way. Yeah.
Jesus.
Yeah.
Man, it's been wonderful. Our last question we always ask is,
Okay.
what's the impact you want to have on the world?
I want to help young people think freely.
Man,
and not be
conformed.
Not be scared
Mm-hmm.
to think freely.
Yeah. Man, that's wonderful.
Yeah.
Thanks for being on the show, man.
All right, Taza.
Really appreciate it.
Thank you.
Cheers.
It's an honor to be invited, and
Thank you.
I really appreciate it. I think that young people are our future, and I really want to give young people more of an opportunity to believe in themselves, and it's great to see people like yourself doing these podcasts. And I feel honored to be a person who is
No, it's been wonderful to have you on. It's such an interesting conversation. We don't have many of these conversations, and it should be more.
Yes.
It's so intellectually engaging.
Yeah.
And you get to think.
Yeah.
In ways you just.
That's
don't
right.
Think.
And it's liberating. It's freeing. That you begin to realize that so much of how we think is due to conventions, to traditions, and those traditions are there for good reasons. But then things change, and we need to have the boldness to be able to think more freely.
Definitely. All right. Cheers.
Cool.
Thank you.
Thank you.